Okay, physics fans, this is Projectile Package Physics 11, and we're on page 12, and we're doing question 24. Excellent question. We're going to go a little bit deeper than the question talks about, but it's a very good question. Here we go. A pilot flying at a constant 225 kilometers an hour horizontally in a low-flying helicopter wants to drop secret documents into his contact's open car, which is traveling at 165 kilometers in the same direction on a level highway 78 meters below. At what angle to the horizontal should the car be in his sights? Angle of depression using displacements, not velocity, when the packet is released. So let's just study this. We have to study the fall of what's going to happen as the package falls. And then we'll start taking a look. So as the package falls here, the helicopter is going to be moving constant velocity that way. And once the package is let go, it's going to fall. We might want to think it does this, but it doesn't. Because as soon as it's let go, it still has the 125 kilometer an hour horizontal speed. Okay, so it doesn't do those dots that way. And if it was just dropped and it wasn't moving, it wouldn't be looking like that. It would look like this. And the dots would get further and further and further apart. But we have to combine those two things together. The dots vertically, so the package would be here. So the path of the package does this. It does falling this way and constant velocity that way, and when we combine them together we get projectile motion. So once it's released, it's going to do projectile motion. Interesting. I think it is. So what speed do we take it at? Do we take the 225? It's trying to land in a car that's going at 165. There's a car, and it's going at 165. And this one's going at 225. So we have to take the relative velocity, and that would be the 225 subtract the 165. That's the closing rate. How much faster is he traveling than the car will be how fast he's catching up to that car, and that's going to be 60 kilometers per hour. So we have to use that as the horizontal speed. And let's convert that to meters per second. 60 divided by 3.6 will be 16 and 2/3. So the initial horizontal speed will be 16.667 meters per second. Way too many sig figs, but let's just do that. And the highway below is 78 meters. The initial vertical speed is 0 because it's being dropped. So this is just a horizontally launched projectile. It's going down at 9.8. So we want to find out how long it takes to fall and how far it travels horizontally in that meantime. When it reaches the height of where the car is, when it reaches the height, let's say the car is driving along there, when it reaches 78 meters down, we want it to have traveled straight. that distance. We want to know that distance. How far does it have to travel horizontally? Interesting. If you were that package or you were looking at a camera of that package, what would that package see when it was looking at the helicopter? Let's try that again. Do it in red. D equals VI t plus 1/2 AT squared, but VI is 0. So this whole term disappears, so we get D equals 1/2 AT squared. Solving for t, we get t is equal to 2D over A. But again, that's only if VI is 0, which it is. Pull up Mr. Calculator, and we take the square root of 2 times 78 divided by 9.8, and that almost take 4 seconds. Oh, 3.990 seconds. 3.990 seconds. So the horizontal range, how far it travels horizontally, still it's the relative range, because we're using the relative velocity here, is v times t, which is 16 2/3 times that. So we take that number and we multiply it by that 16 2/3, and we get 66.496 meters. So it has to be further back, 66.49 meters. Okay. Now the tough question is, what is the angle of depression? It's in his sights. It's visual line of sight. So when he's here and he's exactly 66.5 meters behind the car, that's when he releases it. Okay, so he's 66.496 meters, and this distance down is 78 meters. And we want to know exactly at that time he needs to release it. So how does he know? How does he know? Because of this line. When he knows this angle, that's when he drops it. And we have to use the distances because it's a visual thing, not his traveling. We're not asking what speed it lands at, because its speed is going to be quite a bit more, because it lands at about 39 meters per second. That's about 4 times 9.8 is 39.2, so it's going down about 39.2 and 16 this way. So the triangle for the velocity is still 16 this way and 39 this way, 16.6. So it's very steep. This is 3 times that. Okay, these are about equal. So the angle will be the inverse tan of the opposite over the adjacent 78 over this range number of 66.496. So inverse tan of 78 divided by that number. The angle has to be 49.55 degrees. Okay, Good question. And last but not least, I have skydived. When I climbed out onto the wing of the plane, still holding onto the wing, and the person inside, my instructor, yelled out when it was safe to go, because he was knowing exactly where the drop zone was, where the target was on the ground. And he looked out and said, "Yeah, this is the perfect place. When you let go, you're going to parachute down to there, knowing the wind." And he said, "Let go." What did I see? Most people envision, oh, you're going to actually be dragged behind the plane. Well, no, actually, when I let go, I saw the plane, well, I had more air friction, so I did kind of like this maneuver behind the plane with respect to the plane. So I saw the plane disappearing above me. Pretty cool. I only did it twice. Only jumped out of a perfectly good plane twice. Won't do it again. Anyways, thank you very much for enjoying the show, showing this show here, this video of projectile motion. A very tough question. Thank you very much. Take care.